Today we are going to learn about tangents and some different theorems that go along with tangents. First of all, what is a tangent? A tangent is a line in a plane of a circle that intersects the circle in exactly one point. So if you remember this from the beginning when we talked about vocabulary, that a tangent only intersects at one point. So he's somewhere on the outside, he comes in like this, and he intersects at one point, which will be outside of the circle. Because if he tried to get inside the circle, then he would cross in 2 points and become a secant. So therefore, a tangent will always be on the outside because it's one point that he crosses out or touches my circle. Theorem 1010 says, in this plane, a line is tangent to a circle if and only if the line is perpendicular to its radius of the circle at its endpoint. Now, this is really important. You'll see this come back up when you're starting to go into math analysis and calculus. You'll see this come back up, and I'll talk about something being tangent. If something is tangent to a circle, it always creates a 90-degree angle from our radius. So here, because he is a tangent, there's a 90-degree angle sitting there whenever I would draw a radius up there. So he's always perpendicular to the circle. Which brings us to theorem 1011. If two segments from the same exterior points are tangent to a circle, then they are congruent. Now, a couple things happen with this. One, it would tell you RS is tangent. It would also tell you TS is tangent to the circle. When they're tangent to the circle, they're equidistant to that point that's external S. With that as well, and this is important for what we're going to do in a little while, is if I draw a line here, a radius, and if I draw a radius here, it's tangent to the circle, so there's 90 degrees sitting right here. So that's also an important factor to think about when we are putting basically it all together. So RS and TS are tangent to my circle, they're congruent, but angle R and angle T are also 90 degrees. All right, so let's do some math. All right, so our first example here says, in the diagram, put that up a little bit, sorry. In the diagram, RS is a radius of circle R, that's supposed to be a little circle thing, of circle R. Is ST tangent to circle R? So if ST is tangent, which is this line right here, then what does that mean? Exactly. It means that angle S here would have to be a 90-degree angle, and it means then who shows up with right triangles? Exactly. If Pythagorean theorem is true, then S is a right triangle with 26 being my hypotenuse. So therefore then I can go ahead and do my Pythagorean theorem. So he will be my C because he's directly across from my right angle. Oops, sorry. He's my A and he's my B. So 24 squared plus 10 squared, trying to see if it equals the 26 squared. So let's do some math. 24 squared plus 10 squared is 676. 26 squared is 676. So they are equal, therefore ST is tangent to circle R because of the fact that the Pythagorean theorem holds true. He's a right angle. All you're doing is proving he's a right angle. Now on number 2, we want to find, we say that point B here is a point of tangency, so I'm going to go ahead and draw my right angle. And then it says, okay, find the radius here. So if I'm going to find the radius, I'm going to use the same exact thing I just did from above. I'm going to basically form a right triangle. Well, I did form a right triangle. And I'm going to use Pythagorean theorem. Little catch here. This is my A and this is my B. This whole piece is my c. So I've got to be careful when I'm plugging it in. So r squared plus 77 squared equals 49 plus r squared. All right, recall back to Algebra 1. This piece here means 49 plus r times 49 plus r. So I'm going to have to use what to solve it? Exactly. I'm going to have to FOIL it. So r squared plus, I'm just going to get the 77 squared out. 5,000, was it 5,929? Equals, and that's already there, so I was doing the next line, sorry. So r squared, so I do FOIL, so 49 times 49 plus 49r plus 49r plus r squared. So let me just clean this up. So r squared plus 5,929, 2401 plus 98r plus r squared. Now, this is a bunch of gobbledygook. With that, we know we cannot solve it the way it is. So now I'm going to have to start bringing things all to one side because I have an r squared that has to equal 0. So let's bring everything over. So when I start bringing everything over here, I notice when I bring my r squared over, it goes away and there's no r squared. So in that case, it changes my solve because now I have 5,929 equaling this plus 98r. That becomes a two-step equation. So all I now have is a two-step equation because once that r squared decided to dissipate, now I don't have it. So now I'm just solving a regular two-step equation. So 5,929 minus 2,401, because I got to subtract the 241 from both sides. So I get 3,528 equals 98r divided by my 98, and I get 36 equals r. So what that means is my radius is 36. Doesn't have a unit on it, so it would have some kind of unit if it had a unit. So be careful, because if not, I was going to have to factor or use the quadratic formula, but because my r squared went away, I don't have to do that. All right, number 3. Number 3 says OR is tangent to circle C, and R at OS. So both of these lines are tangent. Find the value of x. So with that, we're going to go back and use that theorem 1011. Remember that theorem 1011 said if two lines meet at that external point and they're both tangent to the same circle, then these two are congruent. So it's a simple equation. So x equals 9. Perfect. All right, moving right along. Oops, sorry. Find x, assume the segments that appear to be tangent are tangent. So if they appear to be tangent, it means they're sitting on the outside of the circle. So it's just basically doing what we just did as well. So on our first example here on 4, this appears to be tangent, so he's my right angle. So now, what are we going to use to solve it? Exactly, Pythagorean theorem. So now when I equals just an x squared, remember I take a square root from each side. Perfect. Okay, on number 2. All right. This 18, first of all, we're going to assume that BC is tangent. So that means here is my right angle right there because it's at the point of tangency. With that, 18 is not AC. 18 is only this portion right here, DC, because he's on the outside right there. AD is the same because he's a radius as AB, so he is also X. So again, Pythagorean theorem. Now remember, he's really written twice, so you need to FOIL him. All right, so now, first thing I want to do is pull that x squared over, and as you can see, I've got the x squared on both sides. Going to dissipate, because it'll be 0 x squared. So then I'm left with a two-step equation, so I need to bring the 324 over. Divide by my 36. Perfect. All right, on number 6. Number 6 is that theorem 10, I think it's 1011 again. So here, when these two sides are tangent to R, they are congruent. Perfect. All right, now we're going to get into ones that are a little more complex, but not really. So on this right here, and I'm going to turn the light on because I have a hard time seeing in the picture. It's just a dark, printed dark, so no big deal. All right, so it says a landscape architect is paving the two walking pathways that are tangent to approximately circular ponds that are shown. The lengths are given in feet. Find the value of x and y. What is the total length of the walking path? All right, so a lot's going on here, and this is where I need to be careful. So here is one circular walk path. So if I forget about this right here, I can use the same theorem I just used in number 6 and solve this right here for x. So x plus 250 equals, that's 4x minus 500. Because they're both tangent to the circular pathway here. So now let me solve this. So I bring the 4x over. I bring the 250 over by subtracting. Do not make that algebra mistake, please. Now I'm going to divide it by 3. So my x is 250. So now I want to do this big one here. This is where it gets a little more complicated. But because I know x, it's not as complicated. It's this whole side and this whole side here are congruent because these two segments are tangent to the circle. So x plus 25 plus the x plus 250 is equal to y plus 4x minus 500. Complicated, but not really. Let's simplify our math a little bit because I like cleaner equations. So 2x plus 275 equals y plus 4x minus 500. At this point, I got great news. I know x. Yay. So I'm going to plug in x. Now let's simplify this mess a little bit here. So I got 2 times 250 plus 275 equals 775 on this side. I have y plus 4 times 250 minus 500 is 500. 4 times 250, that just works out kind of. I guess that's right, that's 1,000, that makes sense. Okay, it's positive 500. It's kind of freaked me out for a minute. So 775 minus the 500, 275 equals y. And I could easily come back and check it right up here because x plus 25, so 250 plus the 25 plus x plus 250, so plus 250 plus 250 had 775 for this side in my calculator. So let's look at the bottom. 275 plus 4 times 250 minus 500 is 775. So I know that these two pieces are congruent, so I know I'm correct. It's just using that theorem twice. Use that theorem twice. And let's just go ahead and use that theorem one more time. So now, in this right here, we say this circle is circumscribed inside this triangle. So, with that, what do I know? Well, I know that when I'm looking at it, if I just look at this piece of it, it's the theorem I just did. So if OJ is 12, JM I know is 12 because it's the theorem I just did. I know if I'm just looking at this piece here, MK is 7, so KN is 7. So I know if I'm looking at this piece right here, that they're congruent. So x plus 3 is equal to 4x minus 9. So I can find x. So let's find x. So x equals 4. Now with that, I already kind of led us into part B. That was for A. So now I kind of led us into part B. Part B says, hey, give me the perimeter. Well, we know the perimeter is the total distance around the outside of my triangle. We know that if he is x plus 3, 4 plus 3 is 7, which it should match right. Well, no, it doesn't have to match right there. Sorry. It shouldn't. It doesn't have to match there. It has to match here and here. So 4 times 4 is 16. 16 minus 9 is 7. So my math does work right there as well. Now to find the perimeter, let's add them all together. So 12 plus 7 makes this side of my triangle 19 for the whole side. That different color. So this whole side is 19. This whole side is 7 plus 7 is 14. And this whole side is 12 plus 7 is 19. So 19 plus 19 plus 14 will give me my perimeter, which is 52. Thank you for spending this time with me. And if you have any questions, you know how to get a hold of us. Thank you.